Hi, okay, so what I'm going to do right now is break down the ISS and how the construction of the ISS is just completely laughable and physically impossible. So I'm going to run through a couple of videos that I've lined up to show you that it's just completely ridiculous. So let's start off showing a vacuum from a train car. These tanker cars are 7/16 of an inch thick, and the ISS thickness of the aluminum body is said to be 1/10 of an inch, which is a little thicker than a soda can, which is just completely ridiculous. Up against a vacuum, would explode. And it wouldn't. It's the same thing with the lunar module that allegedly landed on the moon. Same thing. They said that if they kicked it too hard, they could put their foot through the floor. It wouldn't withstand the pressure. If you've seen a vacuum chamber here on Earth, these things are 4 feet thick steel in order to create a vacuum. It's just ridiculous that they say they could do it. So, anyways, let's go through here and I'll show you a couple different things. First of all, let's look at a train car with a vacuum and see what happens when you have that difference of pressure. There you go. Pretty cool. Okay, so again, that's 7/16, so just under half an inch, and the ISS, which is up against more of a vacuum than that, is 1/10 of an inch, which is, look on a ruler if you're not familiar with measurements. It's ridiculously thin. Okay, so let's go through, and I'm going to show you basically on the copula on the ISS. There are some windows, and basically there's 7 windows, and they have these rods that go through the window, and it's a physical rod that they twist to open up the outside of the copula, and they have to twist it, and the rod goes through to the outside of the ISS and then opens up these swinging doors that keeps them from micrometeorites, right? So because that's going to protect them, that's going to protect them, but the 1/10 of an inch thick aluminum walls that aren't going to keep the vacuum of space out is going to protect them from a meteor flying by. Come on, let's use our brains, folks. So anyways, let's go in here. Check this out. Okay, so let's look at the demonstration. Okay, the audio got really weird because it's loud. So anyways, look at these doors that open up. It's a physical rod that goes from the inside of the ISS to the outside. Look at the bottom right there, how ridiculous it is. It's just flapping down. It doesn't even close. Now this is allegedly real footage from the ISS, and I guess that's Earth down there, and this is live footage. So this is what we're supposed to believe. I mean, it's just laughable. But that rod, it goes right through the ISS and out the other side, and is supposed to be airtight. One other observation from this ESA video I just showed you is the noise. It sounds like you're in a milling factory or something. I mean, where did they come up with this stuff? I mean, they literally have this background noise, and it's supposed to be in outer space. And they put it in there to dazzle you and to throw you off, but it's just so weird. It wouldn't be noisy. So why are they putting that in there?
Okay, hey, it's me, Destin. Welcome back to Smarter Every Day. Now, a lot of the pictures you see from the International Space Station come from the cupola. on the inside here, right? So the cupola is on node 3, is that correct?
Node 3.
Node 3. All right, so this is astronaut Don Pettit. You may know this guy. You've done all the like city tracking.
Yeah, I've done a lot of cities at night, and then the nighttime aurora and time-lapse sequences of Earth. Many of those that you see have been done in this module when I was at the home of the
He's the junk. Let me just say it that way. You're the junk when it comes to space photography, right? Can you say that? Is that I'm the junk?
No, I can't say that because I just...
All
I mean,
right.
look at this. Yeah, this is all real. This is what Don Pettit's taking. Great. Good job. Wow. Let's get out of here.
Now this is the cover.
Okay.
So we call it a shutter, and it protects the windows from micrometeorites.
Okay.
Shutters are closed, the windows are protected. And also thermally insulates the windows from the radiation environment of space.
So can you shut these things from the outside?
No, you can open and close it from the inside.
Oh, okay, wait. On the inside, you're throwing a lever or something.
Yeah, you're turning a knob.
And it's
Open. Yeah.
on the outside.
On the outside.
How do you do that and maintain a pressure seal between them?
O-ring type seals
No, you don't.
with a rotating shaft. All our hatch seals are O-ring type seals.
Yeah, but how? My
It's
brain's
locked up here. Let's go inside. We can see it.
okay.
Watch your head.
All right. Oh.
This is great. I mean,
You have a
this is
whole
great. Like,
series of
they
O-rings in
actually
here.
put this out there.
And a shaft that you rotate.
So I mean, like on the space station, how many of these would you have?
7, because we have 7 windows.
What happens
No.
if you get a leak on
Don
that?
Pettit, real genius.
Then you have a leak.
You just have a leak,
And what you would do
you
is
lose air.
Yeah, you would probably seal the whole cupola off.
Oh,
And then there's probably a plan, I don't know off the top of my head, but there's probably a plan for replacing the mechanism. Might require a spacewalk.
So my question is, how can you operate a lid on the outside of the
okay, let's just stop there for a second. He is one of a few astronauts. I think he was the commander or whether the lead joker on this thing. And he says, I don't know. If there's a leak, I don't know. You know, there's probably some way to fix it, right? And so imagine a physical rod, right, going through, and this thing has to turn back and forth, and there's O-rings inside the wall of the dividing wall that has to rub constantly. For 20 years they've been using this thing over and over. You just saw that display where the guy was just open and close, open, close, open, close, and that rubber O-ring, nothing special, just a piece of rubber, is just perfectly machined and never wears out over 20 years of just rubbing back and forth. I mean, come on.
space station by manipulating something mechanical on the inside of the space station without losing air pressure?
It's called real good engineering.
Okay, you heard Don Pettit. He said that it takes a really good engineer.
So this is the
20 years ago, he was the lead engineer over the cupola shutter design, but after the project finished, he stopped and went and built his own business. Now he's building this. It's a special stand that uses leverage to...
Let's get to it.
This program morphed into the International Space Station program, and Charlie's drawing package was handed over to the Italian Space Agency so the Italians could fabricate it. Charlie, however, kept an entire drawing package because every good engineer knows you might have to go back and look at what you did. We talked about the handles, we looked at the bevel gears, we talked about the cartridge assembly. Okay, we found what might be the most critical part of the entire drawing package. This is the inner shaft, and...
Okay, there it is. So the O-rings sit here, and the wall would be here, and this thing rubs. These O-rings are gonna rub, and this right here was this is on the outside, this is on the inside. So this is going to create the only seal. Okay, and there's 7 of them.
And you can see right here there are 2 grooves, and those grooves are held to within 0.02 of an inch. The reason that's important is because the interface between the inside of that groove and the outer wall that compresses the O-ring, you have to control that because you're taking a circular O-ring and you're going to squish it to an oval. Is that right, Charlie?
That's correct.
There's another detail to those O-ring grooves, right?
Right, these are the dynamic grooves. Those 2 are the ones that actually are turning.
Did you hear what he just said? He said they're dynamic O-rings. That means there's a shaft running through it actually rubbing on the O-ring. So you've got the air that you're breathing as an astronaut, right? And it's being held back from the vacuum of space by 2 little bitty O-rings. That's incredible. So this design...
It sure is. And if that leaked, if they leaked, which they would, because it's a joke, and they used them for 20 years, twisting back and forth. If that leaked, it would suck the air out. Not to mention that the entire ISS is said to be 1/10 of an inch thick aluminum walls, which wouldn't hold the air in anyways. So there is that.
that you made 20 years ago is still being operated today flawlessly. How does that make you feel?
I hope it's flawless.
A couple months ago, I was sitting here and I tweeted something, and I noticed it was favorited from an astronaut on orbit. Blew my mind, right? But if you think about it, it makes sense. These astronauts are getting smart. Anyway.
From our design, right? I never really know.
You don't know?
Didn't follow up on it, no.
Well, the Italian astronaut said that was how it was built.
So that guy even threw together the plan. He didn't even know they used it. So this goes to show how compartmentalized everything is. You know, it's just one guy, he just makes some design, and of course it doesn't work. I mean, it's laughable, but he didn't even know that it actually went into use. I mean, you think that he would be, you know, pretty proud, and they would give him a plaque or something because he invented the most unbelievable machining probably ever been invented, that this rod can withstand the forces of absolute vacuum for 20 years, rubbing back and forth. I mean, it's just like, I mean, that is amazing. This guy should be probably some kind of renowned engineer and be revealed for his machining expertise.
Hello, and welcome to the cupola on the International Space Station. In the cupola we have 7 windows, and every window has its own shutter. And Smarter Every Day,
now she's in space right now, okay?
Asked me to do a demonstration of how we open and close the shutters. I guess it's because I'm Italian, and the cupola...
I suppose in the background here, this must be Earth, because she's looking out the window. So this white part must be Earth. Okay, got the windshield wipers over here, and I don't know, what is this, like a mosquito zapper over here?
You know, was built in Italy. So here we go, it's pretty easy.
Look at this speaker. Look at these screws. The screws are like coming out. There's like duct tape over here. What does this say? Audio terminal. These screws are like backing out of the holes. I mean, this thing is just a complete joke. I can't believe that people actually believe this stuff. It's just comical.
Each window has a handle that looks like this, and you just turn it, obviously in the closed direction if you want to close the window. And here you can see the window coming closed.
Okay, so let's state this one more time to be clear. This rod goes straight through the wall. There's those O-ring gaskets in the middle of the wall. Goes to the outside, which creates a lever or some other mechanism that's going to, you know, raise that window up as a mechanical lever going right through the wall. And that little rubber gasket's the only thing making it airtight on 7 windows used daily for 20 years.
For the shutter. And when you get close to the end, to the closed position, you kind of want to be careful because there is no bumper, so you don't want to hit the structure real hard. It's a direct mechanical connection. Shutters can only be operated manually, and it's kind of cool to think that, you know, there's this shaft that goes sort of through the structure. The other side is in outer space. It feels cold, but a regular metal cold, not really, really cold. And again, when you get close to structure, you want to be careful not to hit real hard.
Which is also ridiculous because it's supposed to be like negative 450 degrees in outer space, and that metal rod doesn't get cold. when it's physically supposed to be on the outside and it's that cold, this thing would be frigid. You don't think that rubber at negative 450 degrees would freeze and crack in a day? Let's consider everything, guys.
So this is it. It's pretty simple. I'm European astronaut Samantha Cristoforetti of the International Space Station, and you are getting smarter every day.
Yes,
Have a good
we
one.
are. All right, so there's that. Now let's go over and visit with Don Pettit again. Mike Massimo, a couple jokers. If you've seen these guys interview before, they talk about how you can look out in outer space and you can see all the stars and the zodiacal lights and all this nonsense. Don Pettit is such a retard. It's amazing that this guy's supposed to be portrayed as an engineer and an astronaut. I mean, the guy literally just came from the loony bin. He's just a complete moron. But all right, so let's see what they have to say about the construction of the ISS. These guys both were up there, right? They were both on the ISS multiple times. And they tell their stories, and they carry on the line. So let's see what they say.
And welcome to the
Inside ISS mailbag.
mailbag. This is a little bit different than what we normally do.
Yeah, but this is a cloud mailbag.
All right.
Some questions.
So that's why we're calling this the mailbag. How thick are the walls of each module?
Oh, they're 1/10 of an inch.
Are you serious?
Serious.
That's it?
1/10 of an inch.
All right, but they're multi-layered, right?
Well, no, the
the
pressure hole itself, the thing that actually protects you by keeping your atmosphere in. So,
Okay, I don't want to be ridiculous about this, but you mean think about 1/8 of an inch, right? 1/8 of an inch. You got a 1/4 inch. You got 1/8 of an inch. Smaller than that. I mean, it's literally barely thicker than a Coke can. Okay, so that's here, 1/10 of an inch, and then they got some foam, and they got some other painted, diamond mesh here. This is what's holding these guys and keeping the vacuum of space. I mean, it's such a joke, and they talk about these micrometeorites coming through, and they could die at any time. I mean, come on.
it's about 1/10 of an inch thick.
That's not very thick.
It's not very thick.
So how do we avoid a hole when we get?
Well-
I thought it was thicker than that. Isn't it different layers to it, or?
Well, the outer layers are the micrometeorite shielding and
That's
the
what I'm
multi-layer
talking
insulation
about.
and all that
Yeah.
stuff.
So how much is that? When I ask you how thick your walls are in your house, you tell me the paint layer? No, you got to go sheetrock and insulation.
Yeah,
you know, that kind of
yeah. Oh, okay, so the paint layer
There we
is, they've
go.
got this really awful green paint on the inside. It's an anti-corrosion aircraft kind of thing
Yeah.
for aluminum prep, right? And then you got 1/10 of an inch of aluminum.
It's hard to watch.
And then there's some like,
that's important because that's your pressure layer.
that's your pressure layer.
the
That's
thing-
what keeps you alive.
Yeah, that's.
And then they've machined.
Okay, let's hear what he's just said again, because he just said the pressure layer is what's 1/10 of an inch. Let's hear that again.
Inch of aluminum.
Right.
And then there's some like,
that's important because that's your pressure layer.
that's your pressure layer.
the
That's
thing-
what keeps you alive.
Yeah, that's.
Okay.
Aircraft kind
Yeah,
of thing
right,
for
right.
aluminum
Listen.
prep,
Yeah.
right? And then you got 1/10 of an inch of aluminum.
Right.
And then there's some like,
that's important because that's your pressure layer.
that's your pressure layer.
the
That's
thing-
what keeps you alive.
Yeah, that's.
And then they've machined this waffle pattern in.
Mm-hmm.
So you have little ridges that are left that almost looks like a waffle. I guess that's why they call it the waffle pattern, right? And
Okay, all right, so enough of that. Yeah, these guys. All right, so there you go. Let me show you one more thing. So anyways, that's all I want to show you. I mean, just how ridiculous the construction is of these things. Look at this. Let's touch one more of 7/16, which is just under ½ an inch under a vacuum of steel. And what happens?
760. Gewonnen hat Herr Dr.
Boom. Okay, so anyways, basically, that would be the opposite. They were sucking the air out of that with the vacuum of space against the ISS. It would explode. So that's about it. Just wanted to run through there and spell that out. And if anybody didn't know, now you know. I mean, it's just a complete joke. I mean, just all the way around. They show all these things about, you know, the harnesses and CGI and all that, which is all, that's happening too. But the idea, the physics and the mechanics of the design of the ISS is the smoking gun. Another smoking gun. They're all smoking guns. I mean, the whole thing is a joke. So anyways, take it easy. I'm going to get out of here and take care. Talk soon.